A great day to one and all. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School SPSGE, and I will discuss with you exercises related to arithmetic sequences, set 3. So for this time, I will be giving you 4 problems that require the use of the explicit form of your arithmetic sequence. So I hope that you will be with me and do your best. But before we have these 4 problems, let us recall the following. That the explicit form of an arithmetic sequence with a sub n equals a sub 1 plus the quantity n minus 1 times d is the explicit form, where a sub n is the nth term of this arithmetic sequence, a sub 1 is the first term, n is the number of terms, and d is the common difference. Now, let's have these items. So here are the 4 items. So we have here 11, 12, 13, and 14. You might think, how come it starts with 11? Because set 1 is from 1 to 5, set 2 is from 6 to 10, and set 3 is from 11 to 14. So please feel free to pause the video at this point. You may solve on your own and verify if you got the correct answer indeed. Without further ado, let us solve each of these items. Number 11. In an arithmetic sequence, if a sub 1 equals 1 and the common difference is d equals 7, find the explicit function in linear function form for a sub n. So for this one, the sequence would actually look like this. Your first term is 1. Since you have a common difference of d, then recursively speaking, to get the succeeding terms, all you have to do is add the common difference. So 1 plus 7, 8, 8 plus 7, 15, plus 7, 22, 22 plus 7, 29, and so on. And to determine the explicit function in linear function form, all we have to do is substitute a sub 1 with 1 and the value of d, which is 7. And in that case, you will have a sub n equals 1, because that's our first term, plus n minus 1 times 7. We did not substitute any value for n because we will determine the function for any natural number n. And if we distribute this 7 here, n times 7 will be 7n. Negative 1 times 7 will be negative 7. That is why you have a sub n equals 1 plus 7n minus 7. And we can still combine 1 and negative 7 into negative 6, right? That is why a sub n is equal to 7n minus 6. So this is now the explicit function of this arithmetic sequence with a sub 1 equals 1 and d equals 7. That is, a sub n equals 7n minus 6. So it appears to be in slope-intercept form, especially if you are studying linear functions when you were in grade 8. And if you could see here, this is an equation in the first degree because the highest exponent of the variable n is 1. And if you could notice, the common difference here is 7, which is as well the slope of your linear function. That's why that is how we relate your linear functions with your arithmetic sequences. I hope you got it. Number 12 is kind of parallel with number 11. Let's have it. Find the explicit function in linear function form of the arithmetic sequence 14, 9, 4, negative 1, and so on, and determine a sub 20 or the 20th term. For this, what we can do is, using again a similar process in number 11, we could see that 14 here is our first term. And to get the succeeding terms, you add by 5, or to determine the common difference, negative 5 rather. You could see that 9 minus 14 is negative 5. 4 minus 9 is negative 5. Negative 1 minus 4 is negative 5, and so on. And we will have n as is. So you will have a sub n equals 14 as the first term, plus n minus 1 times the common difference, which is negative 5. With that, distributing this negative 5 here and copying the rest, you have a sub n equals 14. N times negative 5, it's negative 5n. Negative 1 times negative 5 is plus 5. And we have to arrange this in standard form, or in a form that's having descending powers of n. So we will have negative 5n first, and 14 plus 5 is plus 19. Hence, a sub n equals negative 5n plus 19. That's the explicit form in linear function notation. But what about the 20th term? Since you have now the explicit function, all we have to do is replace all n's of a sub n equals negative 5n plus 19, replace all n's by 20. So you have a sub 20 equals negative 5 times 20 plus 19. Negative 5 times 20 is negative 100. Plus 19 gives you negative 81. Hence, the 20th term of this linear function, or of this arithmetic sequence, is negative 81. I hope you got it. And if you did, great job. But if not, try again. You can do it. Number 13. In a certain arithmetic sequence, the sum of the third and the seventh terms is 52. The sum of the fourth and the 10th terms is 64. Find a sub 21 of this sequence. There are many ways of solving this problem. Others use shortcuts. Others use has to find the value of a sub 1 and b. And for the meantime, I will be presenting to you this solution. Using the explicit form of the sequence, a sub n equals a sub 1 plus n minus 1 times d, we know that the sum of the third terms and the seventh terms is 52. We don't know what the third term is, but if we substitute n by 3, you will have this one will simplify to a sub 1 plus 2b. A sub 1 plus 2d is the third term. And for the seventh term, it's actually a sub 1 plus 7 minus 1, or 6d. And their sum rather is 52. That's why adding them gives you 2a sub 1 plus 8d equals 52. But we can still divide each of the terms by 2 since it's their GCF. So you have a sub 1 plus 4d equals 26. So that's the first equation. 2a sub 1 divided by 2, it's a sub 1. Plus 8d divided by 2, it's plus 4d. 52 divided by 2, it's 26. So that's for the first equation. For the second equation, it says the sum of the fourth and the 10th terms is 64. The fourth term is a sub 1 plus 3d, and the 10th term is a sub 1 plus 9d. That is by utilizing the explicit form of your arithmetic sequence, and their sum is 64. So we have this Simplifying the left-hand side, a sub 1 plus a sub 1 is 2a sub 1. 3d plus 9d is plus 12d equals 64. Also, we could see that each term has a GCF of 2, so dividing each term by 2, we have a sub 1 plus 6d equals 32. All right, so far so good. And you could see we have a system of linear equations. These two in bold here are the equations. What we can do is we may now employ what we call elimination. If you wish, you could also do substitution. So to remove or to eliminate a sub 1, we have to subtract both sides. So a sub 1 minus a sub 1 is 0. 6d minus 4d, it's 2d. And 32 minus 26 is 6. So 2d is equal to 6. Dividing both sides by 2 gives you d equals 3. Hence, the common difference is 3. But we are not yet done. We are looking for the 21st term. Since we have now d equals 3, we may solve for a sub 1 by substituting this 3 to the first or to the second equation. In my case, I chose to substitute it in the first equation. And with that, a sub 1 plus 4d equals 26. I copied it first. D was substituted by 3. So you have a sub 1 plus 4 times 3 equals 26. And 4 times 3 is 12. And subtracting both sides by 12 gives you the first term, which is 14. Since we have now the value of the face of our first term and the value of our common difference, we may now be able to solve for the 21st term of this arithmetic sequence. And using again the explicit form, we have a sub 21 equals the first term, which is 14, plus your n here is 21. 21 minus 1 multiplied by the common difference, which is 3. 21 minus 1 is 20 times 3, which is 60. And 14 plus 60 here is 74. Therefore, even though we have this simple or this quite difficult given, still we were able to determine the first term and ultimately the 21st term of this sequence. I hope you got it as well. And lastly, grade 10, let's have the 14th problem or the last problem for today's video. In a certain arithmetic sequence, a sub 11 minus a sub 6 is equal to negative 25, and that a sub 2 plus a sub 8 equals negative 24. Find d, a sub 1, and a sub 15. Now, for this one, earlier in number 13, it's plus, but right now it's minus. So the process might be something similar. So for the solution, we will still utilize the explicit form of your arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d. For a sub 11, it's actually a sub 1 plus 11 minus 1 or 10 times d. That's why for the 11th term, a sub 1 plus 10d minus the 6th term, which is a sub 1 plus 5d. Note that we have to place a sub 1 plus 5d in the parentheses because you are subtracting the entirety of it. And if you take the difference, then the result is negative 25 based on the given. And with this, if you perform subtraction, you could actually see that a sub 1 minus a sub 1 becomes 0. 10d minus 5d is 5d, and equate that with negative 25. With such, dividing both sides by 5, you get d equals negative 5. So the common difference of your arithmetic sequence is -5. Now, let's utilize the second given, that the second added by the eighth term is -24. Using the explicit form again, we know that a sub 2 plus a sub 8 is -24. A sub 2, or the second term, is a sub 1 plus d. The eighth term is a sub 8, or a sub 8, I mean, is a sub 1 plus 7d. And that is equal, their sum is equal to -24. Simplifying the left-hand side, we have 2a sub 1 plus 8d equals -24. Dividing both sides by 2, or in this case, you may divide or not, it's okay. For my case right now, I substituted immediately the value of d, which is -5. 8 times -5 is -40. So you have a 2a sub 1 minus 40 equals -24. Add both sides by 40, you will get 2a sub 1 equals 16. Dividing both sides by 2 gives you the first term, which is 8. Now that you have your d and your a sub 1, we may now compute for the 15th term. And that the 15th term, using the explicit form, is a sub 15 equals 8 plus 15 minus 1 times the -5. 15 minus 1 is 14. Multiplying that with -5 is -70. That's why a sub 15 is equal to 8 minus 70, or the 15th term is -62. If you got this one correctly, great job. But if not, you can still work on it and practice more. I hope I was able to explain the topic well. And if you have comments, suggestions, or any clarifications, feel free to comment it in the chat box, or feel free to reach me in my social media accounts. With that, before we end, let me leave to you this quote. The beautiful thing about learning is that no one can take it away from you. Let's learn it from B.B. King. With that, thank you very much, and a great day to one and all.